NASA's Voyager 1 spacecraft, which presently holds the distinction of being the most distant human-made object ever constructed, has captivated individuals worldwide for nearly 5 decades since its launch. Voyager 1 has transmitted crucial data from the farthest reaches of outer space, enhancing humanity's comprehension of the cosmos. However, the probe's recent transmissions have exhibited unusual anomalies that have left specialists perplexed. These enigmatic signals have sparked intense discussions, prompting the scientific community to question whether these irregularities are mere technical malfunctions or indications of something far more extraordinary, potentially even extraterrestrial involvement. ft.com+4 science.mnasa.gov+4 science.mnasa.gov+4 Join us as we delve into these perplexing messages and investigate what might be concealed in the vast expanse of the universe. The intrinsic human desire to uncover mysteries has long propelled our quest for space exploration. This profound curiosity paved the way for ambitious projects such as Pioneer 10 and Pioneer 11, which were among the most daring space missions of their era. On August 20, 1977, the launch of Voyager 2 from NASA's Kennedy Space Center marked the commencement of a groundbreaking era in space research. Shortly thereafter, on September 5, 1977, Voyager 1 was dispatched into space, embarking on a journey that would lead it to the outer planets, dramatically altering its trajectory and scientific outcomes. Each probe, with a mass of approximately 721 kg, comparable to a compact automobile, traveled in distinct directions at varying speeds. On December 15, 1977, a significant milestone was achieved when Voyager 1 surpassed its twin in terms of distance covered due to their divergent paths. Since then, Voyager 1 has served as a crucial asset in deepening our understanding of space, providing discoveries that have transformed our comprehension of the universe. Before delving into some of its recent groundbreaking findings, let's revisit several of its earlier key accomplishments. In 1979, positioned roughly 265 million kilometers from Earth, Voyager 1 captured high-resolution images of Jupiter. By January of that year, it had completed an impressive 100-hour study, resulting in a time-lapse sequence that depicted Jupiter's rotation. This set of 3,750 images offered unparalleled insights into the planet's turbulent atmosphere and complex features. During this mission, Voyager 1 also detected a previously unidentified ring around Jupiter and discovered 2 unknown moons, significantly enhancing our knowledge of the gas giant's intricate system. To maintain its course and avoid colliding with Titan, one of Saturn's moons, the probe performed several navigational adjustments. Subsequently, the mission shifted its focus beyond the solar system's planets as the spacecraft was redirected into interstellar space, traveling at an extraordinary pace of 325 million kilometers per year. In January 1990, Voyager 1 commenced its assignment to explore interstellar space, pressing onward beyond the confines of our solar system. During this phase, it accomplished several exceptional feats, such as identifying 4 new moons, Mimes and Enceladus IIs and Rhea, and capturing some of the most memorable images of the solar system's outer boundaries. On February 14, 1990, located approximately 6 billion kilometers from the Sun, Voyager 1 took the iconic family portrait, a panoramic collection of images of the inner planets. This compilation of 60 photographs was added to the probe's extensive gallery, which already featured hundreds of images from its close encounters with the gas giants. Voyager 2, in parallel, achieved remarkable milestones during its journey. It measured wind speeds on Neptune that topped 2,100 km/h, roughly 1,300 meters per second, the fastest atmospheric currents ever recorded in the solar system. It also observed Triton, Neptune's largest moon, where temperatures plummeted to a frigidus 391 degrees Fus, 235 degrees Celsius, ranking it among the coldest known locations. Triton exhibited signs of icy eruptions spewing nitrogen gas and frozen debris up to 5 kilometers high, revealing fascinating new aspects of its geology. These extraordinary discoveries significantly broadened our understanding of the diverse and dynamic conditions in the solar system's outer regions. The impact of both Voyager 1 and Voyager 2 has been truly transformative. Their findings unveiled previously concealed characteristics of Jupiter and Saturn's moons once thought to be inactive. This new evidence redefined beliefs about their geological activity. Voyager 2 in particular made history as the only spacecraft to date to pass close to both Uranus and Neptune. Unparalleled achievement. NASA employed a series of innovative strategies to extend the lifespans of these groundbreaking missions, such as powering down non-essential components to conserve energy. The endeavor is projected to continue until 2030, symbolizing the conclusion of a remarkable chapter for the teams who dedicated themselves to this mission. The construction of Voyager 1 and Voyager 2 exemplified advanced design and engineering built to rotate slowly. These probes minimized motion blur in their images during travel. Even before arriving at the outer planets, the spacecraft began relaying detailed visuals of Jupiter, unveiling its swirling clouds and the well-known Great Red Spot, a colossal storm that has piqued scientists' interest for decades. One of the most thrilling discoveries was the detection of active volcanoes on Jupiter's moon Io. The instruments aboard the spacecraft picked up peculiar readings from the moon, later validated by images revealing massive volcanic plumes and a violently reshaped surface. One eruption on Io was found to be 1,000 times more forceful than Mount St. Helens, blanketing an area nearly the size of France. As their voyages continued, both spacecraft were gradually powered down to save fuel before heading into interstellar space. Strikingly, they didn't capture images of Mercury or Mars. Due to technical constraints, NASA later launched additional noteworthy missions, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Pioneer 10 surpassed Pioneer 11 to become the most distant probe from Earth. Nevertheless, Voyager 1 continued its journey for another 14 years before officially penetrating interstellar space. On Voyager 1 discovered 4 additional moons orbiting Saturn: Mimes, Enceladus, Tuz, and Rhea, while also delivering stunning visuals of the planet and its rings, revealing their intricate structures in remarkable detail. The mission's excursions to Uranus and Neptune yielded essential insights into their atmospheric behaviors and satellite characteristics, enhancing our grasp of the solar system's remote territories. After concluding their planetary flybys, both spacecraft charted a course into interstellar space, where they continue to gather vital scientific information. This ongoing data collection broadens our viewpoint on what lies beyond the familiar boundaries of our solar system. As researchers anticipate fresh developments from Voyager 1's peculiar emissions and what they could imply for our cosmic understanding, the awe-inspiring odysseys of these probes persist in motivating scientists and space enthusiasts around the globe. Their accomplishments have become foundational milestones in expanding human comprehension and advancing the frontiers of astrophysics. The Voyager programs have offered unprecedented perspectives on our solar system from regions once thought inaccessible, providing iconic imagery and invaluable empirical data beyond their scientific roles. The spacecraft carry symbolic artifacts, messages intended to portray Earth and humanity to any potential intelligent extraterrestrial civilizations. The golden record aboard. Each Voyager contains greetings in 55 languages, musical compositions from diverse cultures, and natural sounds such as thunderbird song and whale calls. This interstellar message stands as a hopeful attempt to communicate across the stars. Voyager 1 and 2 were equipped with a suite of scientific instruments that vastly improved our understanding of space. These included magnetometers, plasma wave sensors, and imaging devices, all instrumental in analyzing the characteristics of space environments. The magnetometers revealed the structures of magnetic fields surrounding Jupiter, Saturn, Uranus, and Neptune, and how these fields interacted with surrounding particles. Plasma wave detectors provided clarity on how solar winds influenced planetary atmospheres and space weather patterns. One of the mission's standout triumphs was delineating the limits of the heliosphere, a massive bubble of charged solar particles and magnetic fields that envelopes the solar system. As Voyager 1 neared this boundary, it recorded a shift from solar wind particles to interstellar material, yielding crucial insights into how this boundary shields Earth from high-energy cosmic radiation. The spacecraft identified a region known as the termination shock, where solar winds slow down and compress. Beyond that lies the heliosheath, a chaotic area where solar and interstellar particles interact turbulently. Voyager 2's similar observations significantly enriched our understanding of this region as well. Notably, its flybys of Uranus and Neptune allowed it to collect essential data, particularly regarding Uranus's magnetic field, which was found to be tilted at an unexpected angle, defying prior models and theories. These findings have since sparked continued investigations into planetary magnetism and its origins. These scientific breakthroughs have not only advanced our collective knowledge, but have reignited public interest in space exploration. The striking photographs of distant worlds and the compelling narratives of these missions have inspired countless people over the years. Spectacular visuals such as Saturn's magnificent rings and Jupiter's erupting volcanic moons have become symbols of scientific wonder, encouraging the next generation of researchers, engineers, and explorers. As the Voyager spacecraft persist in transmitting extraordinary findings, their extended ventures through interstellar space present unmatched opportunities to decode the universe's most fundamental mysteries. While initial attention was focused on the planets within our solar orbit, venturing into interstellar domains has uncovered surprising complexity. Regions once believed to be void now display intricate processes that challenge long-standing scientific models. Among the most fascinating discoveries is the detection of cosmic rays that originate beyond our solar system. These extremely energetic particles traveling close to the speed of light offer valuable clues about processes in distant galactic regions. By analyzing their composition and energy, scientists hope to better understand the forces at play in faraway star-forming zones and the overall dynamics of the Milky Way. Moreover, as Voyager 1 and 2 plunge deeper into interstellar space, their onboard instruments continue assessing the density and flow of the interstellar medium, the thin matter made up of gas and dust that fills the space between stars. This medium interacts with solar wind and plays a major role in shaping the structure of the heliosphere. By navigating through it, the probes supply indispensable data that assist researchers in constructing models of how energy and matter behave across vast cosmic distances. In addition to these contributions, the Voyager missions have illuminated crucial aspects of interstellar magnetic fields, offering new perspectives on their properties and how they influence the broader galactic environment. Such insights could one day lead to breakthroughs in understanding how magnetic forces affect the structure and evolution of the universe. The continual investigation of these far-off frontiers not only extends our scientific horizon but also inspires future generations of astrophysicists and aerospace engineers. The unforgettable images captured by Voyager, especially the legendary pale blue photograph of Earth taken from over 6 billion km away, serve as a sobering reminder of our planet's fragility and modest place in the cosmos. These photographs, combined with the mission scientific milestones, have profoundly shifted humanity's perception of itself and its location within the universe. The success of the Voyager missions has laid the groundwork for even more ambitious undertakings. The technological innovations developed during their journeys now make it increasingly feasible to send advanced probes to previously unreachable parts of the galaxy. Aspirations such as exploring exoplanets, identifying potentially habitable environments, and even achieving interstellar travel are gradually transitioning from speculative dreams into realistic objectives. The future of space discovery stands on the shoulders of these trailblazing missions, Voyager 1 and 2, which continue to redefine the boundaries of what's possible in space exploration.